Welcome back to Applied Mathematics. This video is on multiplying rationals. We will also get into dividing rationals and raising rationals to various powers before the end of the video. But for right now, let me get my head out of the way. There we go. And remember that a rational expression is something that involves a polynomial divided by another polynomial. So if we are multiplying rationals, we're going to be multiplying these polynomials times another set of polynomials. Okay. Before I get into actually solving this problem, though, I want to go off to the side and remind us, how does multiplying work when you're dealing with fractions of a much simpler variety? Two-thirds times 5 over 11. The rule for multiplying fractions says that you multiply across the numerator, you multiply across the denominator. 2 times 5 is 10, 3 times 11 is 33. A trick that you have almost certainly seen in multiplying fractions is to make your life easier by remembering that you have to reduce before you're done. So if you have something like 9 over 16 times 4 over 15, yeah, we can multiply 9 times 4 over 16 times 15. But if you stop and you think about what you're doing for just a moment, you might remember that 9 is 3 times 3, 16 is 4 times 4, and 15 is 3 times 5. This 3 cancels out that 3, this 4 cancels out that 4, and we're left with 3 over 4 times 5, which is 3 over 20, and we don't have to worry about getting the big numbers. Because on one hand, sure, you have a calculator. You don't have to worry about writing out 16 times 15 by hand and figuring out what that's going to be. You can just punch it into your calculator and see that it comes out as 240. But if you do that, now you have 36 over 240, and you have to scratch your head and identify that there's a common factor of 12 between 36 and 240 in order to reduce from there. If you have a very modern calculator, it can handle even that step for you, but most calculators cannot. And certainly, if we come back over here to the expression that I have written out, that is not going to be something that we're going to be able to handle. In the expression I have over here, there's not really anything I can do with x squared plus 9. There's not really anything I can do with x minus 3. There's not really anything I can do with x plus 2. But I can look at x squared minus 9 and remember that that factors into x plus 3 times x minus 3. By identifying that, I can cancel out the x minus 3, and I can write my solution, x squared plus 9 over x plus 3 times x plus 2. And as far as I'm concerned, that is a good place to leave your result. Yeah, you don't have to multiply out that denominator. Because working with rationals almost always means step one, factor at least the denominator. Leaving your denominator in factored form does not hurt any future use and is considered by a lot of mathematicians to be the simplified form of the expression. Of course, that's not everyone, and so if you wanted to multiply that out and write the rational as x squared plus 9 over x squared plus 5x plus 6, that is also perfectly fine. There's nothing wrong with it. It absolutely works. All right, moving onward. How about some division? Okay, so remember, again, dealing with fractions with whole numbers in them. If I have 3/5 divided by 2/7, I would leave the first fraction alone, change division to multiplication, take the reciprocal of the fraction on the right. In this case, I end up with 21/10. The same rule works when you're dealing with dividing rationals. So if I have x over x plus 7 divided by 3 over x plus 5, I will leave the rational on the left alone. I will rewrite my division as multiplication. I will take the reciprocal of the other rational. I chose this one as a simple example where you don't have to do anything with factoring. We can just multiply across. And once again, you can leave your result here, but most students tend to find it much nicer to multiply this out. X squared plus 5x over 3x plus 21. Right. For my purposes, I will take either of those possible solutions. Again, depending on context, depending on where you're going from here, one or the other might be more appropriate. The last example I have for you is raising a fraction to a power. Let's say 3/5 to the 4th power. The rule of exponents says that we can split this up as 3 to the 4th over 5 to the 4th. 3 to the 4th power is 81. 5 to the 4th power is 625. Yes, I have those memorized. No, there is no value whatsoever in having those memorized. But the important thing here is that whenever you're raising a fraction to a power, you tend to end up with a result that has some really ugly numbers in it, right? 81 over 625. Trying to figure out how that factors does not feel pleasant. It's not something that I want to do. Luckily, a nice property of mathematics, the fundamental theorem of arithmetic, which involves prime numbers usually, but it also tells us that as long as the fraction that we are dealing with to start, 3/5 in this case, has already been reduced, then after you raise it to a power, you will not be able to reduce it further. Right? So raise a fraction to a power, it is already reduced, nothing else you need to do. Although powers don't have to be positive numbers. For example, I might have 2/7 to the -3rd. I tend to think about negative powers in 2 steps. The negative and the cube. Properties of exponents tell us that if we are going to take a fraction and raise it to a negative power, that forces us to take the reciprocal. Right? 2/7 to the negative first power is 7/2. And then we still have the cube going on. So we'll have 7 cubed over 2 cubed, which comes out as 343/8. That same logic works whenever you are dealing with a rational expression. So if I have x plus 1 over x minus 1, the whole thing raised to the negative second power, I can take the negative first, which is going to take the reciprocal of the fraction. So I will have x minus 1 over x plus 1, the whole thing to the positive second power. Then I will split that power up. I will have x minus 1 squared. I will have x plus 1 squared. And then finally, if I so desire, I will multiply that out. Right? X minus 1 squared is x minus 1 times x minus 1. X plus 1 squared is x plus 1 times x plus 1. So we're going to get x squared minus 2x plus 1 over x squared plus 2x plus 1. And even though those two things look so similar and there is so much temptation to try to reduce from there, because it's addition and subtraction and not multiplication, there is nothing we can do. It does not reduce any further, and that is our result. You can give it in that form. You can give it in this form. I'm not going to be picky between them. All right. I went a little bit quickly through all of that. There is a lot of information in this video, but I think that that's enough. Right? Again, as long as you are comfortable with the operations on fractions, the fact that we have moved on to rational expressions where we have polynomials instead of just numbers really doesn't make things that much more challenging. I don't have anything else to say, so I'll wrap up the video on that. As always, thank you for joining me, and I'll see you next time.